Okay, my name is Borys Neselovskyi. I am working at EDB, Enterprise DB, and today we will speak about the Postgres database. I know DevOps conference, databases, yeah, maybe it's not really fits, but we will speak about the automating of installation, provisioning, and also administration of database, especially of Postgres database. About me, very short. Yeah, I'm born in Ukraine. The last 27 years I'm living in Germany. Have two sons, wife, and I has been worked about 25 years with Oracle technologies. I was Oracle architect in database, middleware area, Oracle engineered systems like Exadata. The last 3 years, I'm working with Postgres for EDB, and I'm helping my customer to adopt open source strategy and especially PostgreSQL database. I was Oracle Ace, Oracle community ambassador because I'm speaking on different conferences and now I'm leading by DUAC, Germany Oracle User Group, middleware stream, and I'm trying by Oracle user also to provide, to show the way to use open source. Okay. Agenda. What is Postgres? Yeah, we will speak about reference architecture, common reference architectures in Postgres. I will show you the tools and methods to automate the installation and also administration of Postgres. I will speak very little time about our Kubernetes operator for Postgres. We can discuss maybe if the databases fits to running on Kubernetes. I can say yes, yeah, and let's start. I need to go. Now I will speak very shortly about my company. EDB or Enterprise DB is created from creator of PostgreSQL community. The first person in the community, Bruce Momjan, Mr. Postgres, is my colleague. Why the colleagues created the firma, the company? Because the big companies coming to community and say, yeah, okay, Postgres is great database, but we need the tools. Yeah, they need high availability, security, they need monitoring and some other things. Yeah, and you are providing us just the database. And it was one reason to create the company. Second reason is several customers need software vendor like support for the database. Yeah, and these two areas are our main actions, main things that we provide for the customers. Yeah, we are around the world. We are worldwide leader in providing of services for Postgres. And if you are using Postgres, you need to know that more as 30% of code is written by my colleagues. For example, partitioning, streaming replication, just-in-time compilation, parallel querying. Everything is written by colleagues who are, works with me. And this picture show you very short what we contributed to Postgres more as Microsoft, Amazon, and Google together. Okay, let's start with referenced architectures. The Postgres, the databases are very complex software. Yeah, you need to think about high availability, backup, recovery. How can I save my data? Yeah, what is happening if my database fails? Yeah, all these things. If you are new in Postgres, yeah, you need to figure out all these things. We created for the customer, for our customer, and also for the guys who are interested in Postgres, referenced architectures. these templates that you can use, yeah, to create different architectures with Postgres. You can just use these templates. You can adjust templates to your own needs. And we have 3 core architectures and also several other architectures yeah, to use. You can just go to GitHub and download this community or search in the community. You will see several architecture for single node, for multi-node, high availability environments. You can also see some architectures for monitoring, connection pooling. How can you make a backup and recovery, for example? And you will receive some tips and tricks to sizing, to layout of storage, layout of operating systems. Yeah, you can see that this repository is maintained by my colleagues Dave Page and Vibha Kumar. Dave Page is member of community core team community member, is author of PG admin tool, is very known tool in the community Postgres, and Vibha is one of the best performance tuning specialist worldwide. You can just show this is very interesting stuff. I learned it as I migrated myself from Oracle to Postgres. I learned a lot from this repository. Okay, before we will speak about automation of Postgres, I will very short describe 3 core architectures. The first one is single node. Yeah, it's very easy to install. You have one VM or you have bare metal server, and you install just a PostgreSQL database. It's okay, yeah, for development, maybe also for tests, because if your database fails, you don't have any redundancy. Yeah, you need to recover your database from backup or from one tool, ETL tool, and yeah, you can spend the time. And 2 very important topics, yeah, RTO, recovery time objective. Yeah, it's time to go online after my failure, and recovery point object, how data can I am permitted to lose. It depends of your recovery strategy in this case. It's good for testing development. You can take a single node architecture, but if you have production, if you have mission critical databases, you need somehow some redundancy. You need some techniques for high availability. And with second architecture, multi-node with asynchronous replication, you have in this example 3 databases, one master database and 2 replicas or 2 standbys. All transactions where is written to the master, committed to the master, will be replicated to the replicas in real time. It means that you have copies of your master database. If the master database fails, one of standby or replicas can take the role of the master, and you will be very quick online. It means that you can achieve very good RTO, recovery time objective. Your database can be again online, can be start again after some seconds. Yeah, if you have some mechanism to automatic failover. What is about RPO? By asynchronous replication, the master can receive all transactions and then send this to standby database. Master will not show if the transactions are already applied on the standby, and in this case, if your master fails, the transactions that are not committed on the master and they are on the way to the standby can be gone lost. Yeah, you can lose this transaction. This is multi-node architecture with asynchronous replication. Is good for about 95% of cases, of use cases. But sometimes you have requirement to have all data. You are not permitted to lose the committed data. And for this one we have multi-node with synchronous replication. Multi-node with synchronous replication is for the databases if you don't allow to lose the data. All transactions will be committed on the primary if the primary will receive feedback from standby that the transaction is committed. It's very safe a method to avoid the data loss, but if you are not able to write to standby, your master database will freeze because master database is waiting for feedback. By synchronous replication, you need to decide the proper architecture. You need to decide to have at least 3 standbys and play with some parameters. Okay, now we are able to speak about the automation of deployment of Postgres database. We know we have 3 core architectures: single instance, multi-node instance with synchronous and asynchronous replication. And we at EDB looked for some tools for automating. We look at Terraform, CloudFormation, Ansible, Shift, and other tools with agent loss. And we started also some survey regarding which tools are popular, and you can see Terraform Ansible was the winner. And we started to create our own tools based on Terraform and Ansible. All these tools that I mentioned today are open source, are free to use. We have several tools, enterprise tools, proprietary tools, but all things what I will say today is open source. You can just download, you can just use it. Okay, the first tool is EDB Ansible. With the help of Ansible roles and playbooks, you can create any architecture. You can create single node, multi-node clusters. You can configure backup with Barman or PG backrest. You can also configure the high availability. The most common tools in Postgres area, like AFM, Rep Manager, and also Petroni. You can configure monitoring with PEM, Postgres Enterprise Manager. You can configure connection pooling, and also you can create Postgres on Kubernetes. About Postgres on Kubernetes I will speak later. It's open source. It's up you to use, to download. You can just use our templates. You can adjust for your needs. How it works? Okay, it's clear. GitHub, download the repository, make install, and now you can install our Galaxy Ansible collection. The Galaxy Ansible collection includes some sources to administration and maintenance of databases, of existing databases. And you can start just, in Ansible is very common, just playbook, host, and something will be installed. What do you need? You need 2 files. One file is playbook. You need to configure this file one time, and this is definition file. This file includes Galaxy collection binding, configure repository access, Postgres version, Postgres flavor, because we have community Postgres, we have also our own Postgres advanced server with Oracle compatibility and so on. And you will describe all roles. Yeah, the roles are already provided by EDB Ansible. And this file you need to configure one time and use by all your installations of different architectures. Second file describes your environment, because Ansible you need to create some virtual machines, your storage, you need to create maybe a bare metal network and so on. And this file describes your operating systems, your machines. Yeah. For example, by this PEM, I will describe Postgres monitoring, Postgres Enterprise Manager. Ansible host is the public IP address, yeah, for the access on the web interface. And maybe you need to have a private network to communicate with databases, with agents. With Barman PG Backup server, you will create the backup server. And the databases, you have tech primary database, and you can say, okay, please create me a Postgres primary database, and this database should be monitored via PEM, and I need also to configure the backup. And you have standbys, and as you can see, you can configure synchronous standby, you can create asynchronous, and this file will you create yeah, 4 databases, yeah, one master, 3 standbys, one monitoring server, one backup server, and will also configure backup and monitoring completely automatically. We talked about core architectures. Yeah, to create to single node, yeah, you need to adjust your inventory YAML file and just provide information for the database. And now you are able with Ansible Playbook to install this environment. If you need to create multi-node, yeah, you can change inventory YAML, Ansible YAML will be unchanged, and you can just say, okay, my primary host, please my standby host make the standby one with synchronous replication, because I need to avoid to lose the data, and second standby can be synchronized as asynchronous. Maybe I can achieve also the geographic redundancy. Yeah, I can put my second standby in other data center or in other region. Yeah, think about your geographic redundancy also. And with the same command, I can just install my environment. And the third example showed you how to install, yeah, everything. Yeah, I have standby, I have master, I have barman, I have backup and recovery, I have monitoring. I need to change only my inventory YAML file and install my environment. So my laptop is running now environment with 7 server, this master 3 standbys, with barman, with monitoring, with one witness server for high availability, and it was very easy to install. Yeah, you need to spend maybe a little time to understand it, to create your inventory YAML file, and then you can use it. Yeah, it's free for you, it's open source, and it's very yeah, good, and several of my customers are using it for automatic of installation of Postgres. Okay, I talked about Ansible Galaxy collection. Yeah, we created our environment, is good, but yeah, the life is going on, and we need to administer our databases. With help of Ansible collection, we can administer our databases. I can create the new users. I can create grant the privileges to user, or grant some roles to my users. I can also adjust some Postgres parameter. You know, the file PostgreSQL.conf, you can set or change some parameters. You can add the entries to pghba.conf file. This is the Postgres firewall file. You can create the new databases. You can set up the extensions in Postgres. And you can configure, for example, logical replication. Yeah, you can create slots, logical slots, if you want to, to have logical replication between two databases with different major version. Yeah, you can do it. And you can also execute the queries, SQL queries, and you can copy and execute SQL files in the databases. Yeah, and also file pgpass is for password loss access for the database. You can also make it, change it and edit this file. Okay, reference architectures, EDB, Ansible, and this both tools are for creating the databases on VMs or bare metals on premises, yeah, or in the cloud, but in your own managed cloud. Yeah, you can create VMs in the cloud, and then you can run Ansible EDB. Several customers asked us to automatically creating of infrastructure as a service with Postgres in different cloud by different cloud vendors. And we created the tool EDB Terraform. With EDB Terraform, you can create in free big cloud vendor by AWS, by Microsoft Azure, and by cloud, different cloud services. You can create networks in the cloud. You can create in the cloud VMs. VMs are already configured for Postgres with some portion of storage for vol files, for data files. The VMs are configured according best practices for Postgres. You can configure Kubernetes services with Terraform, and also some database, managed database, RDS, RDS Aurora, LODB by Google, and also Flexible Server by Microsoft. You need to clone the repository, and then you will receive some templates for Terraform. And these templates you can use or you can adjust templates. You can generate your Terraform scripts with EDB Terraform. And then you can just start Terraform init, Terraform apply, and entire environment will be created in the cloud. It's very, very easy to use. You need only Python 3 for this. Then you are able to create your Postgres databases and environments in the cloud. Good. We talked about the classic vault, yeah, VMs, on premises, bare metal. Can we run the Postgres in the new modern world in Kubernetes? Do you have any experiences with databases in Kubernetes or in container? Okay, yeah, not too much, yeah. Yes, we can do it. Databases are complex, and in Kubernetes, stateful applications are the problem, because you need the very good storage connection. Yeah, you need and several storage driver are not very good for the database and Postgres also. And we created also one Postgres operator in last year by KubeCon in Valencia. We released it as open source. I'm really very proud of my company because it's a lot of work. The team of eight guys was developed this, and now it's open source. All guys can use it, yeah. And this is really very good operator. Why? This is the first operator, is completely declarative operator. It's written in Go, and you need only the YAML files, definitions for all operations, and you need some Kubernetes. Yeah, you can use it in Kubernetes, vanilla Kubernetes on premises. You can use it in AWS, Azure, or Google Kubernetes services. You can use it in OpenShift and in any environment what you have. Rancher, VM Tanzu, everywhere. Yeah, because you need just kubectl and your YAML files. We are delivering several features. High availability. We don't need for high availability third-party tools because we are using the strengths of Kubernetes, readiness, liveness, if the master will fail. We have automatic failover. We're creating with each cluster TLS certificates. Our connection between nodes are encrypted, and connections to the client also encrypted with TLS certificates and secrets. We have backup and recovery, rolling upgrades. You can scale down and up the read replicas. We have native Prometheus exporter. We have Grafana dashboards and several other things. And you need just YAML files. Yeah. How it works? Yeah, you can just go to GitHub Cloud Native PG, download the project and use it. How it works? To install the operator, you can use manifest file, just kubectl apply, or you can also use Helm charts. And the operator is installed. And now you are able to create your first cluster. Creating of free node cluster in classic way, you need to create free VMs, you need to set up your network, you need to install Postgres, create first cluster, copy cluster to the second node, make some changes. Yeah, you can automate it with Ansible, I know. But here we can do it with just one YAML file and with kubectl apply. How it works? This is my YAML file. I have a kind cluster, name of the cluster. I can define 3 instances. First instance is master database. 2 instances are replicas. I can set, okay, I need my synchronous replication also. I can create the storage, yeah, and one portion of storage for the PG data, for the data, other for the transactions, yeah, whole storage. I can adjust several parameters. I can also create my own secrets, my own import my own certificates and several other things. Do we have time? Okay. Yeah, and this is all what I need to create free node cluster with high availability, with synchronous replication. After kubectl apply my file, the operator creates the first node, the storage, and also the pod, and it will be my master database. We don't install the Postgres in these pods because we have the templates, we have the images, yeah? We can just download, the operator will download the image and start it, and the Postgres is running, yeah? It's about 1 minute, 2 minutes, 3 minutes to install entire environment. The operator will install the Kubernetes read-write service. Read-write service is responsible to all client request would need to read-write, yeah, to master. It would always point to the master. Then operator created a second node as standby and will start the replication from the master. operator will create service read-only. If you have, for example, only selects or need to create some reports, yeah, you don't need to go to the master, yeah, because you can just read from the replica. And then the third replica will be also created and synchronized. Yeah, one file and you have entire environment. You can set, if you know in Kubernetes, affinity, anti-affinity, yeah, to make sure that your nodes are in different locations, in different regions. You can do it, everything with YAML syntax. But okay, what's happen if my master database fails? Master or primary? The Kubernetes detects the fail of the database, of the pod, and tell operator, okay, you need to look, yeah, it's something wrong. Operator is looking and say, okay, yeah, database is not available, I need to make failover. Failover means I need to change the roles. My standby, in best case my synchronous replicated standby, will take over the role of the master. Now we have my app DB2 as primary. My read-write service will automatically reconfigure it to go to this new master. It means that the clients don't need to change connection string because they are using IP address or server name of this my appdb read-write service, and service will just point on the new master. In the next step, the replication will be configured between new master and existing standby, and last step is just old master will be started and the new standby, and replication will be also established from the new master. Everything is happen automatically. You don't need to make some actions as DBA. Yeah, this is strengths of Kubernetes and also strengths of our operator. Okay, all these tools that I described now are open source. You can use it. My company have several proprietary tools. Yeah, we can help you with configuration setup of Postgres databases. But I'm really proud that we are doing also community work, yeah, and we do for our customer and for Postgres fellows really very good projects, and you can create, you can learn about the reference architecture from the best specialists of Postgres in the world. You can create your Postgres with Ansible and Terraform if you need to, if you want to use VMs, and you can also start the journey with Kubernetes. Yeah, and I hope the next time I will see more hands would say, yeah, I tried. Thank you very much.